Welcome. We are the project for LaTrobe University 3D Digital Twin. Our team is called 127001 and consists of Wright Thomas McLean 217-23607, Shaman McLean 217-08080, Michael Kamari 212-59437, Dagash Dubai 225-57335, and Joshua Bonfa 212-21738. The LaTrobe University 3D Digital Twin is a replica of the campus infrastructure operations and activity patterns. The project continuously monitors real data from buildings, energy systems, labs and shared spaces so staff and students can view the university and see scenarios safely before making real world changes. This facilitates teams which predict equipment failures before they cause downtime. Sustainability teams can model carbon and energy saving planners which can trail new space usage timetables and safety policies without disrupting teaching. The LaTrobe University turns the university into a smart software environment that is easy for management, safe operations and sustainable to run. The LaTrobe University campus 3D digital twin is a virtual replica of physical assets that is synchronized with through real-time data. This is designed for university management and presentation for the university website. Our scope objectives: provide real-time visual understanding of real room and zone states, enable quick decisions, review trends, presenting a navigatable 3D model that mirrors the building layout and live status. In-scope features: live status, campus and building, floor model footplates with metadata, real-time highlights, dashboard. Out of scope: campus and building 3D shell with metadata, camera controls, screenshot export, camera controls. Enhanced student experience: students can access room availability and locations for suitable study spaces, lecture rooms or breakout areas. This creates a seamless on-campus experience and the reduction of frustration caused by overcrowding or unavailable rooms. Operational insights for campus management. Facilities and faculty teams can monitor how spaces are being used, enable smarter scheduling and resource allocation. This creates more seamless on-campus experience and reduces frustration caused by overcrowding or unavailable rooms. Future expansiveness for a full campus twin. The system is designed for a scale beyond a single building for coverage of the entire university campus. As additional data sources are integrated over time, the 3D digital twin can evolve into campus-wide visiting and planning platforms supporting long-term sustainability, smart infrastructure and strategic investment decisions. The project team 217001 consists of Wright Thomas McLean 217-23607. The team member brings a programming expertise which enables the project to progress. The team member progressed with the other students well. The team member designed and implemented the real-time data pipeline that does connect live campus system data. The team member built the predictive analytics layout that estimated equipment stress and flags emerging faults before they become outages. Ryan makes the digital twin not just a visual but operational, useful, reliable enough for faculties for acting on and explainable enough for the stakeholder to trust. The project team member 217-001 consists of Shani McLean 217-08080. The team member is focused on designing, developing and maintaining reliable, scalable code, responsible for all aspects of planning and requirements gathering to oversee back-end integration, final deployment and immersive features. The team member led stakeholder engagement with IT services, sustainability and campus operations for the needs of clear technical requirements for the digital twin. The member manages the system, preparing the production environment, handling access control, making sure the digital twin which can go to work with the existing university systems without breaking. Project Team 217001 consists of Michael Camilleri 212-59437, contributed to the project in the own way, which should have contributed across the project whenever support was needed. They should collaborated with the team during design development, testing, presentation, preparation, and were involved in discussions around how the digital twin should meet real stakeholder needs. The flexibility and willingness for ownership of tasks would help the group deliver a complete working solution. The project team 217001 consisted of Dukesh Dubai 225-57335. The team member did not take part in requirement gathering, design decisions, development work, testing, system validation, development or deployment preparations. The team member were not directly involved in delivering core features of the digital twin, including live data ingestion, predictive analytics, scenario simulation, or instant reply compliance tooling. The project team 127001 also consists of Joshua Bonfa 21738. The team member worked well with the team, supporting their communication, and could take part in the requirements gathering, design decision development work, testing, system validation, document and deployment preparations. The team member was not, however, directly involved in delivery of the core features of the digital twin, including live data ingestion, predictive analytics, scenario simulations, or instant reply compliance tooling. The user stories for the LaTrobe University 3D digital twin would include user story 1, identify a building at glance. As a map user, I want to see the outline appearance of the campus digital 3D map, so icons on a flat map but has a 3D building structures that represent orientation, height and shape. The campus gives a sense of space and geography, helping with the navigate the campus intuitively. The acceptance criteria would include 3D models of the building are visible from the moment of the scene loading. Each building should have a label and hover over name. Camera zoom, orbit adjust without clipping into buildings. Buildings should be distinguishable by silhouette or material. The success measure would include, as a first time user, could be recognizable campus layout with 5 or 10 seconds. User story 2, building information on click and hover. As a map user, the click or hover on a building to see its key information, so to quickly learn what it is used for or whether searching externally. The extended narrative would be the name of the building would be hover or click. The key information could be accessed so that they could quickly learn what it is used for without searching externally. The acceptance criteria would be tool tip over hover, expand information panel on click, name, building code, purpose and hours at minimum, camera focus and highlight selected building. The success measure would be selecting the building services information within 1 second. Campus orientation and navigation. As a map use, the navigation would be for around the campus in a 3D situation, so that the explanation of how buildings are positioned and get realistic scenes of campus layout and direction. The extended narrative would include the experience would feel intuitive, like walking through the campus virtually. I should be able to orient from the student center, rotate around teaching precincts, or zoom towards landmarks like the library or sports center for the understanding relative distance before physically going there. The acceptance criteria would be smooth, zoom, orbit and pan. North and south orientation reference visible. No clipping into the terrain. The success measure. Users should maintain spatial orientation at all times. Using story 4, highlight buildings and filter. As a map user, the issue is to filter and highlight buildings by their type or function so that visually can be distinguished as academic, administrative, research and student building services. The extended narrative would be that the instead of scrolling through its list, should be able to view all teaching buildings at once or highlight student services building when support is needed. The map should visually communicate with the categories. The acceptance criteria toggle filters by category, only filtered building, highlight or other grey or dim. Legend, visitor, explaining, shading or colours. These success measures would be that can visually locate all buildings of the criteria in less than 8 seconds. User story 5, zoom out to campus level context. As a map user, the zoom out to full campus views so that I can see the LaTrobe University as a single connect environment, not just individual buildings. The extended narrative would be the digital twin would allow a macro view of the campus layout, roads, pedestrian corridors, clusters of buildings, give a holistic perspective of campus structure. This prepares for future expansion into zones, precincts, or multiple campuses. The acceptance criteria would be campus level boundary minimap or box, smooth zone transitions, clear distinctions between major zones, performance stable at full campus view. The success measure would be full zoom out target on a standard laptop. Future facing scalable campus expansion. As a map user, the map is designed to scale to additional buildings and precincts in the future, so that the twin is understood as a growing platform rather than a static visualization. The extended narrative would be the initial vision could include a subset of buildings, but there would be placeholders or clearly defined structure organization for expansion to the rest of the campus. This communicates long-term strategic intent. The exceptions criteria would be additional buildings that appear for placeholders, UI convey status, map boundaries consistent with full campus scope. The success measures would be stakeholders can envision the digital twin scaling to the entire campus. The user story outcomes would be the view buildings in 3D, click building for info, navigate a campus, filter by function, zoom campus wide and future scaling. The outcomes would be the contextual understanding, orientation and exploration, purpose based on discovery, macro perception and long-term twin platform. Design, limitation and evaluation discussions. Design discussions. So the LaTrobe University 3D Digital Twin is designed as a lightweight based web experience. This focuses on displaying the exterior of the university buildings in a clear, accessible and intuitive way. The layout and structure of the campus from a bird's eye perspective. The core design goal is not to simulate building materials or complex data. The Chrome website presents the campus as an interactive digital map, which each building would be represented in 3D form. Users would be able to zoom, pan and reorientate the view for explanation with the campus visually while interacting with the building. This simple information panel tooltip provides key contextual details such as the building name, its academic function and its category. Design intentionally focuses on clarity and accessibility rather than technical depth. For delivering experience through HTML website, the digital twin remains easy to load platform, independent and viewable on common devices like laptops, tablets and low-select computers instead of relying on complex simulation logic. Design emphasis on user orientation and toolkits. Visual clarity and simple navigation cues making useful for the first-time visitors, new students and campus tours. Limitations. The limitations would be exterior only, static information, no route planning, no real-time analytics and performance tied to the device. The description would be the model displays only outside of buildings. Buildings show the informational context but not live status. The website supports visual orientation but not indoor pathfinding. The digital twin is visual only and 3D rendering still depends on browser compatibility. The limitations are expected at this stage and are consistent with campus visualization priorities, usability and clarity over technical complexity. Evaluation. The success of the version is evaluated not by technical metrics like sensor accuracy or latency, but usability outcomes. However, the website does help people understand and navigate the campus visually. Usability. Can a first-time user recognise the buildings and their location? Could they identify buildings by their purpose? Do they find it intuitive for rotating, zooming, exploring the map? Clarification of orientation. Does the 3D perspective users understand how buildings relate spatially? Does the map reduce confusion about the campus layout, accessibility and reach? Does the format allow anyone to view with minimal loading time? Does the site work with hardware that is normal without specialized software or hardware? Summary. The version of the digital twin would be presented focused 3D visualization of campus exterior buildings designed for the enhanced spatial awareness student experience and early stage digital campus engagement. The 3D digital twin intentionally lightweight, accessible and easy to deploy, forming of a function for later upgrades that could introduce interior navigation like data analytics or sustainability overlays. Project deliverables and milestones.
Project deliverables. The outcome of the project would be fully functional website that visually represents the exterior buildings of LaTrobe University in a simple, accessible 3D twin format. The deliverables would be designed for the demonstration of the technical implementation and user value of the system. The main deliverables will be interactive 3D digital twin website, includes map navigation and building information panels optimized for browser with no additional installation requirements, a standalone site showcasing external structure of university buildings, 2. Building data and visual assets, a curated 3D model, texture and campus imagery, metadata for each building, static content structured for easy future updates and scaling for core buildings, 3. Design components and user interface, informational tooltips and responsive layout as multiple screen sizes, accessibility features including readable contrast, navigation menu, building category filters and campus overview map. 4. Documentation package. Developer guide explaining the structure and assets are organized. User guide describing the navigation for the 3D map and access building information. Project report including design discussion, limitations and evaluation. 5. Demonstration and media assets. Screenshots of the campus map and information panels were for assessment purpose. Short demonstration showing key user stories and interactions. 6. Future extension outline. A brief proposal describing how the system would expand into a full digital campus twin with live data integration, interior mapping and sensor connectivity. Project milestones. The milestone would be the 1. Project planning and conceptual approval, 2. Data and asset preparation, 3. Interface layout and navigation design, 4. Building information integration, 5. Filtering and characterization, 6. Testing and optimization, 7. Documentation and demonstration media, 8. Final presentation. The activities would be to define the project scope, develop user stories, select initial building models, collection and refining of building data, metadata and visual materials, optimization of 3D building models for browser performance, building the HTML structure, navigation bar and map interface for the implementation zoom, rotate and pan functionality. Connect to the building data to interface, enabling hover and click events for displaying building information, adding functionality for the filter or highlighting of buildings by type, for example, research, academic, admin, or services. For the testing of usability, performance, and accessibility, adjusting for mobile and laptop screens, preparing the final documentation, user guide, and demonstration video, showcase project, answer questions, and submit all files and documentation. The expected output would be 1. Approval of the design concept and project plan. 2. Ready to use 3D assets and data. 3. Working prototype with basic navigation. 4. Interactive information panels displaying metadata. 5. Filter buttons and category coloring active. 6. Stable, responsive and user-friendly websites. 7. Completed report and demonstration video. 8. Final graded submission package. The summary statement. The deliverables would be demonstrative of a complete and accessible 3D experience that does allow for users to visually explore the exterior of the LaTrobe University campus. Each milestone bends progressively from the concepts and data collection to interactivity and presentation, which ensures that the final website is functionality, visually engaging and scalable for future expansion. In conclusion, for the digital accessible environment, the development of the LaTrobe University Digital Twin represents a step forward in this goal. The project demonstrates how modern web technologies are, even when implemented through a simple base platform, it is effectively communicated spiritual awareness and institutional identity, user engagement without requiring complex hardware or software. The goal of this project was to design a lightweight, intuitive web interface that visualizes the external structure of the campus buildings in an interactive and visually meaningful way. The focus would be on exclusive building exteriors. The project successfully balances the technical simplicity with strong visual impact, providing scalable foundations for the future expansions such as indoor mapping, sustainability analytics and sensor data. The deliberate scope would be to ensure that the system would be accessed easily through standard web browsers, removing barriers for the usability, ensuring inclusivity for all students, visitors and staff alike. The design perspective, the project highlights the importance of the clear visual hierarchy, accessibility and interactivity in digital mapping. The user can identify buildings at a glance, access information panels with essential metadata, and navigate the digital campus map. The design does adopt a minimalist and user-friendly layout to ensure that the visual experience remains consistent across devices and screen sizes. The impactfulness of the project extends beyond the current functionality. For the student, it enhances the campus orientation, enabling them to quickly locate and understand key buildings before physically visiting the site. For administrators and planner, it provides a foundation for visual campus management and spatial planning, potentially integration for future datasets like occupancy, energy efficiency or accessibility services. For the university as a whole, it serves as a demonstrable step forward to the larger vision of a smart, digitally connected campus ecosystem, one that merges physical and digital experiences for better communication, learning and sustainability. Despite its achievements, the project acknowledges its limitation. The current version is static, providing only exterior visualization without real-time data or internal spatial details. The digital twin does not yet include live updates, sensor feeds, or complete analytical components. However, these limitations were intentional and strategic. The clear defining scope boundaries, the team ensured that the system remained stable, efficient, and visually engaging rather than over-engineered and difficult for deployment. Future development would build upon this framework with integrating devices, real-time data, APIs, and extended features like navigation paths and energy analytics, therefore transferring the prototype to a complete operational digital twin. The results show that users find the website intuitive, visually clear and engaging. Participants in early usability testing were able to identify the buildings within seconds, understand their function and comfortably navigate the digital campus view. Performance tests would demonstrate that the website-based structure loads quickly and runs smoothly, even on laptops, confirming that accessibility and performance goals could be achieved. In summary, the LaTrobe University 3D Digital Twin project demonstrates that a simple website can act as a powerful platform for visual communication and digital transformation. This successfully fulfills its initial objectives, providing interactive campus visualization tool that could enhance student experience, offers operational insight, and lays the groundwork for full-scale expansion across LaTrobe University. For establishing a visually rich yet technically lightweight digital foundation, this project positions the university for evolving into a more connected, data-driven and sustainable campus in the future. Ultimately, this proves that innovation does not depend on complexity, and sometimes meaningful change begins with clear vision for accessible technology and a commitment to continuous improvement. Thank you.